Hi, welcome back to Key Concepts in Technology. This is the introduction to Week 8. This week we will explore how computation and software developed beyond earlier applications and contexts for business, military, and government to become the general purpose computers like our PCs, but also as our multimedia platforms for creating, transforming, transmitting, and displaying any form of digital media content, from simple text and photographs to high-definition movies and 3D. In the readings this week, we'll follow a line of development discussed by Lev Manovich in the book Software Takes Command. This is a fascinating story of creative development that takes basic models of computation and combines them with the more user-centered interfaces to software functions to become, in Doug Engelbart's famous phrase, augmenting the human intellect. The HCI community develops out of an awareness that computers are cognitive artifacts and can be taken in any direction that we can design. That awareness has motivated the great design principles. While they're not always followed in commercial products, they lead directly to the multimedia computational devices that we use today. In the 1950s, during the first commercial rollout of computers in the business world, few people could have imagined how computation, software, and digitization could become universal information processing platforms for all media. Now, many forces and technical developments had to come together in these perfect storms of convergence to give us the results that we know today. And there's a fascinating backstory you can explore on all this history. But briefly, using the model of complex interdependent network systems of agencies and intelligence that we've been working with, we can map out the necessary dependencies that enabled the convergence of software, better computers, and the technologies for digitization, for display equipment, and most important, the breakthroughs in human interface design concepts. Now, all of these ideas and technologies came from different places, different industry groups, and different players. But someone was coming along to optimize them all. There was a major turning point in the late 1960s and 70s that changed the whole idea of what a computer can be. And in many ways, we're still using and implementing these design concepts for computation and digital media. They came out of the Xerox PARC Research Lab and groups at MIT in the 1960s and 70s. Now, this group of engineers were rethinking computing on creative principles and included people like Doug Engelbart, who invented the mouse as a graphical interface controller and the desktop metaphor for the screen interface, and Alan Kay, who conceived and modeled a multimedia tablet computer that he called a metamedium, a medium for representing other media, long before it was possible to build it. Now, Alan went on to work at Apple, and his design concept was used in the first Mac interface. And now all interfaces in all Apple products and all the PCs and tablets made by many other companies. Kay's idea was to use computation and software processing accessed in a graphical screen interface to allow people to do their own learning and creating things. So instead of thinking about a computer as a medium with its own fixed rules and properties, he saw the potential for computers to morph into a metamedium, a medium for presenting, transforming other media. Almost everything we take for granted on our graphical Windows-based PCs and responsive touch tablet devices comes from Kay's extensible design principles. We say extensible because the design principles define an open system for new combinations that couldn't be foreseen in earlier implementations. Remember, combinations lead to further combinations. There's a good story, and I don't remember the source, but I have to repeat it now, about Steve Jobs and Bill Gates. Now, the rivalry between Apple and Microsoft and between Bill and Steve personally is legendary. Now, when Apple was able to combine the components to implement the Xerox PARC ideas for a graphical interface and layers of screen windows using the desktop metaphor, it was a good proof of concept for a computer that anyone could use. And Microsoft's first Windows operating system soon followed. Now, people complained that Microsoft had ripped off the Apple design, but in fact, they both appropriated design concepts from the same source. In response to charges from Steve Jobs that he had ripped off Apple, Bill Gates supposedly said, "Actually, Steve, we both have a rich uncle at Xerox PARC, and we both snuck into his office one night and took a bunch of stuff that we're all now using." So you'll find many examples of re-implementable and extensible design concepts. The design principles that give us our software-driven multimedia world connects back to our unit on modular combinatorial design principles. There's no limit to the number of functions, processes, or transactions we can develop in software and implement in an architecture of a smartphone or a tablet. For example, we continue to add new apps, and people will continue to figure out new combinations as these design principles get extended. Just like there can be no longest English sentence or a longest novel, there will always be the next iteration of extensible combination in software for a design that integrates social functions, digital media, communication modes, and transactions in newer value-added ways. We'll continue exploring the consequences of how computation can be designed into an integrative user interface and the Metamedia platform that gives us the information and content on all of our devices.